Alright, so welcome to video number 4. Okay, we just saw the game on page, like the example 276.2 in figure 277.1, and we described that game in detail. Now what we're doing is we're thinking of the expected payoff of player 1 if player 1 has observed the signal y1 and player 1 is choosing either B or S, and that is conditional on the strategy that is followed by player 2. So if player 2 chooses B always, irrespective of what signal she observes, and player 1 chooses B, then player 1's expected payoff is 2. This is very similar to what we did earlier in the previous variant of Bayesian, where player 1 always wants to meet player 2, but player 2, her type is unknown to player 1 and only known to player 2. So if player 1 is of type 1 and is considering her actions of whether or not to choose B, so to choose B or S, the expected payoff matrix will look exactly the same as it did earlier when player 1 just had one type where she wanted to meet player 2 and was unsure of player 2's type. So just convince yourself, read the text, or I hope I've convinced you that in this game, so the previous example of Bayesian is equivalent when you're calculating these expected payoffs to a situation where player 1 has already observed y1, knows her type, and then choosing B or S. So these are the expected payoffs, and now what I want you to do is to do exercise 277.1, which will allow you to calculate the expected payoffs for both players, for both types for each player. So there will be 4 such matrices that you will want to calculate. For this matrix is player 1 of type y1. So player 1 that has observed the signal y1. So the other matrices will be player 1's expected payoff when she observes n1, player 2's expected payoff when she observes y2, and player 2's expected payoffs when she observes n2. So that is what I want you to draw out. Do exercise 277.1. That's basically this. The solution is given in the solutions booklet thing that is already uploaded on Canvas. So you can take a look at that for inspiration. Alright, I'll see you in video 5, and I want to see all 4 matrices here.